Dear students, today we will discuss on controlling of slip ring induction motor drives by using slip power recovery method. In last video, we already discussed on operation of slip ring induction motor and controlling methods of slip ring induction motor drives. So today we focus on slip power recovery method. What is the importance of slip power, which is generated by the slip ring induction motor? So here give some information about slip recovery power method. So basically slip power recovery is one of important scheme for control the speed of induction motor drive. There are two types. First we describe static Kramer drives and later on we describe static Scravius drives. So first you look in static Kramer drives. We control the speed of drives below base speed. That is the means below synchronous speed. If any motor having a synchronous speed 1000 rpm or 1500 rpm, then we control the speed of this drive below synchronous speed. That is the means below 1500 rpm or which have motor 1000 rpm, then we control below 1000 rpm. And second things, the feature of this drives maintaining a constant torque, and this drive is operate unidirectional. That is the means the power flow in the unidirection, only one. What in the second method, the power is flow y-directional. So for understanding this method, we look this circuitry is met. Here we give the three-phase supply, and this is the wound rotor induction motor. Actually this scheme, this methods use only wound rotor induction motor. It's not a squirrel case. So here describe wound rotor induction motor. So here we get the slip power, and which feed to the diode rectifier, and this is the reactor, a smoothing reactor. This is known as also DC link. Here we get the DC out, and this will give to the inverter, and inverter convert to DC, fixed DC in a variable AC. So here we put transformer, a step up transformer. So this power step up by this transformer and given to the three-phase supply. So this method is called slip power recovery method. For understanding, we give some relations. Mechanical power developed by the shaft of the drive induction motor equal to Pg minus PR. That is the means Pg power developed by the air gap and minus power loss by the rotor of induction motor. So this is the net mechanical output power, PM equal to input power minus loss. So here another expression, the rotor losses PR, which is introduced by PR, equal to SPG. That is the means whenever S is increases, then rotor losses will also increase in terms of PG, where S equal to slip. Slip is already defined the ns minus nr upon ns. So here basically the principle for working of induction motor. Here induced EMF in S times of P2. So these are the all parameters affected by slip. Now come to second method. Here we talk slip power recovery or power electron waste rotor side control slip ring induction motor by the static Scaravous drives. This is second method for controlling the speed and torque of slip ring induction motor. So the feature of this drives, in this method we control the speed of drive both above or below synchronous speed. That is the meaning, if any drives have a specification or synchronous speed is 1500 rpm, so then we control the speed by this method above 1500 rpm or below 1500 rpm. That is the meaning of above, below and synchronous speed. And this method work as a y direction. That is the means sometimes if we demand this motor power, so we give the feedback of this system. Whenever we need give the excess power, then we this direction. When we need some power for the operation of the drive as demanded by the load at a particular speed, so this method work as a y directional drives. In conclusions, if maximum slip is denoted by S max, then power rating of diode, bridge rectifier, inverter and transformer. Actually these are the three basic components of this drive. So can we adjust S max times of the motor power rating, resulting in low cost of the drive. So this will be a low cost drive. This static Scaravous drive circuit diagram provide a constant torque control. So this method work on constant control. With constant torque, we control the speed below and above rated speed. So this is the advantages of this drive. If you constant power control is obtained by first method, static Kramer drive. So some limitation here for slip recovery power method is used only wound rotor induction motor. And advantage, it is an energy efficient drive. That is the means we save the energy by using of slip power recovery method. So it is an energy efficient. But some disadvantage occurs in this drive. First, operating cost is high and it produces harmonics in the system because of it uses a diode rectifier or inverter IC. So it introduces some harmonics and this will be deteriorate a supply. And the application of static Scaravous drives, that is known as slip power recovery method. The static Scaravous drive has application in large power fan and pumps drives, which require speed control in narrow range. So these are the specific application of this drives. I hope you have learned of this topic is clearly. Thanks.